Hello, everyone. I'm Yuan-Tsung, and this is Zhi. And it's a great honor to be here to share our findings. Today's topic is Ethereum packet of death. In this talk, we are going to discuss a series of vulnerabilities that, if used by a attacker, could possibly lead to 60% of Ethereum nodes crash or freeze in just seconds. And we'll have live demo. Zhi will help me with that. So first of all, let's take a look at the status of blockchain. As shown in the figure, blockchain had got more and more attention in the mid of 2017. And here are some numbers. In 2017, there were more than 1,000 decentralized apps and over 700 tokens that are tradable, and keeps growing. In 2018, the whole market cap of cryptocurrency is bigger than 330 billion. Well, it goes down a little bit to about 250 billion. But if you take Ethereum as a country, its GDP is ranked 28th in the world. That is somewhere between Norway and Iran. So with the growing market cap, cryptocurrency also become the new victims of cyber criminals. Starting from early 2014, the Mt. Gox bankruptcy, to recent security issues. MyEther wallet suffered from DNS hijacking. BEC SMT tokens, the ERC20 smart contract bugs, to Bithumb, a South Korea-based exchange, hacked with $31 million. Each of them could directly or indirectly cause some serious financial impacts. And as you can see from the list, these incidents occurred from exchanges to smart contract to digital wallet. So every component in the ecosystem might have some potential security issues. So what are the components of the ecosystem? Well, we have infrastructure, layer nodes all over the world that compose the network. Mining pool, they contribute most of the computation power of blockchain. And the layer smart contracts, decentralized apps, digital wallets, exchanges. These are different kinds of blockchain applications. Smart contract is a great innovation of Ethereum. We've done lots of research on them. These vulnerabilities are discovered and disclosed by PeckShield. The batch overflow, you may have heard of. It caused several exchanges to suspend their ERC20 token, suspending for trading. And this is on the list. This series also discovered by PeckShield, but not yet disclosed. We are still in the process of communicating with the project teams and token issuers. We will discuss them once we think it's safe to do it. But you can check our website for full list. Anyway, these are not the topics we are going to talk about today. Instead, we're going to talk about another very important part in the ecosystem, the infrastructure. The infrastructure are literally the building blocks of blockchain. But not many security researchers pay attention to it compared to a smart contract. However, if any critical bugs found, it may compromise the whole network. So in Ethereum, the clients are the infrastructure we mentioned in previous slide. And we have many different kinds of clients. We have GAS, the Golang implementation, C++, Python implementations. These three are from the Ethereum Foundation. And we have another very popular client, Parity. And you can tell from the figure, the market share of GAS is about 2/3. And the Parity occupies about the remaining 1/3. So since GAS is the majority of Ethereum client, it is our first priority target of research. But what are the are the attack surfaces of a guest node? Well, it depends on the exported interfaces. So we may have EVM-related issues from smart contract. We may have RPC interface issues from different endpoints. And we may have protocol stack issues from other Ethereum nodes. And this is the part we are going to dive into today. So here's a brief introduction to the protocol stack. We will not go to details, just give you a simple picture for background knowledge. As you can see, the protocol stack consists of layers with different functionalities. On the top of that, there are various subprotocols. And each subprotocol supports different messages for requests and responses. The security issue we're going to talk about why we're using LES. LES stands for Light Ethereum Subprotocol. It is used in Light client. They download block headers only, and they don't mine. They don't take part in the consensus process. So they are pretty lightweight compared to a full node. Thus the name, Light Ethereum. So as we mentioned, each subprotocol supports different kinds of messages. And LES supports status message, announce message, and others. But there's a code flow in get block headers message handler. It is the message that used for a client to ask headers from LES server. And this figure shows the buggy part. We'll have detailed analysis in the following slide. So the above figure tells us the parameters used in the handler. A node could use it to specify the start block numbers, the amount of headers it wants to retrieve, and the number of blocks it wants to skip between consecutive headers. However, the handler doesn't have sanity checks on all parameters. So an attacker could launch attack with a malicious packet. Upon receiving the request, the victim will first try to allocate a buffer with size equals to secret plus 1. And that is -1 plus 1. So it actually allocates 0 size buffer. Then it will try to create a return buffer with the index skip. And it will lead to out-of-bound read and crash the node. So we'll have a live demo for this. Can we switch? OK. So first of all, we'll download the guest binary from the official website. And you'll notice that we are not downloading the latest version because we've reported this bug to the Ethereum Foundation, and they fix it in the latest version. OK. So next, we'll compare the MD5 to the official website. And you can see, anybody see any difference? I can post here if you want to compare. No? OK. So try it. And we'll start a node with the option to support LES protocol. OK, now it is running and syncing. Next, we can open a TCP dump window with the filter to monitor only traffic from the default port. And we turn off the Wi-Fi to make sure there will be no outside traffic. So everything's ready now. And we can run our exploit. So let's drop the bomb. OK. So you can see through the window that it crashed. And it tells you that the root cause is indexed out of range, as we analyzed this before. And if you pay attention to the dump state, you can tell that the guest node was in the middle of handling some message. And if you look back to the Ethereum window, we only need one packet to kill the remote node. So, ladies and gentlemen, Ethereum packet from the death. Okay, let's switch back to the slide. So, what are the possible impacts? What are the consequences or victims of this attack? Well, an attacker could use this to attack a known node. So, exchanges could use it to attack another exchanges, to attack their competitors. Mining pool could use it to attack other pools to eliminate their computation power. Or you could use it to attack boot nodes just to disturb the Ethereum network. So we strongly recommend every user to upgrade their gas to latest version. Okay, here's another one, the codename's Freezer. We reported it to the Ethereum Foundation on May 29th, and they confirmed it a couple days later. But as of this talk, the page is not ready yet. So after discussing with the Ethereum Foundation, we decided not to disclose any technical details, but we'll have a video demo. Can we switch to demo? Okay. So first, let's download the binary from the official website. And you'll notice that we are downloading the latest version, and it proves that the patch is not ready yet. It is not fixed. And we compare the MD5. Sorry about the resolution, it's low. But I guarantee you that they are the same, okay? Okay, then we start the node. So this is now running and thinking. And next, we launch our freezer. And you can notice in the middle of the left upper bound, there's a line that goes up gradually. There's the memory consumption. So okay, so you see that the guest node is freeze. It is not responding. It can function normally. And if you look at the system monitoring window, it will tell you that your gas consumes almost all of your resources. So freezer not only freeze your gas node, it could possibly also freeze your computer. So we will demonstrate two dangerous bugs. As we mentioned before, every component in the ecosystem could have potential security issues. And the list two dangerous bugs could possibly lead to 60% of Ethereum node crash or freeze in just seconds. As a security company, we want to contribute to co-work, cooperate with the community to build a better blockchain ecosystem together. That is our vision. Okay, I hope you enjoyed the presentation. That's all for today's presentation. And you could check our website for follow-up. Also, we are hiring. Okay, thank you.